after spending 23 years in the US Air Force, where he's a commander, space operator, and a certified acquisition officer. I don't know what that is. But
I don't know.
the other
Certifiable.
The other two things I'm sure about. And he also did tours at the Pentagon, the NRO, and the Air Force Space Command. He's a former SpaceX vice president for mission and launch ops and customer operations and integration, and with more than 200 space launch missions under his belt. During his 10 plus years at SpaceX, he led the build of 3 Falcon 9 and Falcon Heavy launch pads, was responsible for operations and mission management of all military, civil, and commercial training. And in 2022, he co-founded ThinkOrbital. That's what we're going to hear about the work tonight, where he serves as president and chief strategy officer. I had the privilege of visiting Lee in his new premises up in Boulder a few weeks ago. And I kind of knew what he was doing, but until he showed me, I didn't realize how cool it was. And so that's what you're about to see tonight. So please join me in welcoming you.
Okay, stand up. Stand up. I'm Scottish, so I wish that was with me, but David was fun. Raise your glass to a toast. Repeat after me. Effort is laudable. Perseverance divine. But results are the only thing that matter. And success is the only thing they pay us for. So success.
Next week's finals week.
This is good. You're allowed to sit back down. Thank you so much for coming out tonight. It is an honor and a pleasure to be here. It was so cool that you brought this Scottish weather for me as well. So I felt at home. David, you are a national treasure in 2 countries. It is so wonderful to be here. And thank you so much for having me. I want this to be a conversation, right? I don't want to talk at you. I want to talk about why we need a new space economy, what the new space economy is, and how we can prepare to take advantage of all the things that the new space economy will offer. And I think it's very helpful to think and talk in analogies, right? You're all normal human beings. And when I think about the new space economy, I think about the gold rush days, right? And you had to have a train to get you out west, right? And you had to have picks and shovels to mine the ore. And those are the guys that really got rich, was the folks that provided the picks and shovels. It wasn't necessarily the gold miners. So remember that back. And then what did they do? They built these frontier towns, right? Back in the olden days. So that's kind of the premise for how I see us in the new space economy today. Anybody challenge that? Believe it? Don't believe it? Okay, you're all right. This is a good analogy. You're okay with it? Okay, good. Okay, so in the gold rush of the new space economy, what's the train that gets us out west? It's the orbital express that is SpaceX. And I had the honor and privilege of working there for 11 years. I can tell great Elon stories anytime you want, so feel free to ask questions. But SpaceX has changed the fundamental way that launch is done, right? It has made it reliable. It has made it low cost. It has made it a much higher cadence than it ever had been in the past. When I was commander at Cape Canaveral in the Air Force, our big launch year was 9 launches. SpaceX does that almost in 2 weeks, right? So it's changed fundamentally over the past 10 years. The access to space and assured access is a really important piece, not only from a commercial perspective, but also from a national security perspective. So you've got to be able to get to that place where the gold rush is happening. And that's what SpaceX has fundamentally brought to the fight, in my estimation. The picks and shovels are something that people don't really think about, right? And what basic tools for how do we actually do things in outer space, right? And 60% of the US economy is based on joining 2 pieces of metal together. Think about that, right? 60% of the US economy joining 2 pieces of metal together, whether that's a semiconductor or an automobile part, right? Yet the United States as a country has never done this in outer space. Doesn't seem right. And as far as infrastructure goes, what's the biggest structure in outer space? And you people from Houston better know this. The ISS. Well, what is the ISS? What's that? The International Space Station? Good, because we are an acronym-free company, so I'm good. We have a strict NAP, a no acronym policy. So, the International Space Station, been a wonderful science, station for us for many, many years. It's aging out and things like that. But what is it? It's really a series of tubes that are connected together, right? And has anybody ever gone to a science fiction movie?
Yeah.
In this audience, you better say yes, right? My goodness, you better say yes. So when I go to every science fiction movie I've ever seen, doesn't have a series of little tubes connected together. They have these ginormous ships, right? But they're not launched from the ground into outer space, right? How did they get there? And I hope we have to think in science fiction terms. Otherwise, we're in deep trouble and we can't get beyond where we are. And the ISS again has served us well for decades now. But it's a series of tubes connected together. If you want to build big things in outer space, where do you do it? Do you do it on the ground and try to cram it inside the payload fairing of a rocket and shoot it into space? Or do you build it in situ, where you need it? And that's the fundamental premise of my talk tonight, is that if you want scale in space, you're not going to do that by building it on the ground and connecting Legos together in outer space. Great for getting us there, great for having a human presence for a long time in outer space, but in the long run, it's just not sustainable, and you cannot achieve the scale that you need to build that new space economy. How are we doing so far? All right, okay, good. So, how did we evolve? We evolved by having tools, right? And you can see old Krug there making a wheel. And that's basically where we are with building things in outer space today. We've never joined two pieces of metal together. Now, the Russians will claim they did it back in the 70s and 80s. And on Skylab, we melted some metal back in the 70s. But effectively, we have no tools to actually build things in outer space. So, what do you need to build things in outer space? You got to be able to join two pieces of metal together. You got to be able to make sure that when you weld things together, that it's going to stick and it's going to work and it's going to be airtight. I don't want to go into a space station that you can't inspect to make sure that you have good weld integrity and things like that. And with additive manufacturing, it opens up a whole new character for how we can build things in outer space. These are things that we don't do today. And everyone's like, what do you mean we don't have these tools available to us today in outer space? But we don't. And that's what my new company, ThinkOrbital, and again, this is not meant to be an advertisement for ThinkOrbital, but I think it plays in well to what we're trying to do to foster and enable the new space economy to grow. And what kind of things would you do in the new space economy, Byron?
Everything I do on Earth.
Everything you do on Earth, and maybe some things that you can't do on Earth, right? Hard to grow, corneas that don't necessarily. Oh, there's a doctor, right? Yeah. How do you print tissues in outer space today?
I mean, you can't, right? But if you could, things would be a lot better.
Right, because I don't have to have support structures for printing tissues and lattice work to hold it up in a 1G environment, right? I can make pharmaceuticals with new chemical compounds, and the way that convection happens in a microgravity environment is very different than how it happens here in a 1G environment. Yet we've not really taken advantage of that. And when I talk to the pharmaceutical industry, and they have an experiment on the International Space Station, and they get 5 grams of finished product back from the International Space Station. They're like, oh my God, this is amazing. I'm like, well, what would you do with 50 tons a finished product. They're like, well, number one, we would help a lot of people here on Earth with those finished products of new pharmaceuticals that can't be made in the 1G environment. And number two, we'd all be rich. So in my estimation, those are both really good outcomes that we need to make happen. So what we're doing is we're building that basic toolkit, allowing us to do simple things like welding in outer space, cutting in outer space without generating a ton of debris, right? The only cutting that's been done in space today is basically a hacksaw or a grinding wheel that basically takes metal, heats it up, and flings it off. Well, when that metal's going 17,500 miles an hour and you're in a spacesuit, you're going to have a bad day. So you've got to be very careful with that. And then the ability to inspect that work that you just did is also very important from a quality assurance perspective. And then to be able to take advantage of the new technology that is 3D printing, again, never been done in microgravity in the vacuum of space, right? So those are the main technologies that we are focusing on as we move to enable and build the infrastructure for that new space economy. Feel free to interrupt anytime you like. Seriously.
All right, I have a
Yeah.
question.
Yeah.
Redwire has been doing some experiments with, bioprinting tissues and stuff. Is that, are you working or envisioning working with some of those companies, or do you have a new approach?
No, we are. Again, I am not a biomechanical engineer. I am not a doctor that works on, doing implants for children's corneas and things like that. And you should have David. Yes, American hero here. Yeah. I want to build the infrastructure. The boring stuff of the place where the doctor does surgery, the place where I store that debris that David talked about, right? And aggregate the debris. We can talk about that because I think that's a fantastic application for large infrastructure in space. And why not? We're there. Let's talk about it. So, what am I going to use this large infrastructure in space for anyway, right? And in my estimation, the infrastructure allows you to scale, right? To build big things. Do you know any pharmaceutical factories that are, about 20 feet in diameter and 30 feet long? No, right? It's not economical. It's not a way to have those economies of scale that you need to build a new economy. So you gotta build big stuff, right? And that's kind of what we're focused on. And debris is the same way. Let me ask you a question. When the recycling truck comes to your house, does it go to your house and grab a can and then go back to the recycling center and then come back and get the bottle that you had and then come back to the recycling center? It makes absolutely no sense. You have to aggregate that debris and bring it together. And we were fortunate enough to do a study with a company called Cal Morris, who's a space debris collector, little satellite company, and this little college called Massachusetts Institute of Technology. They're no Rice University. I think they're the Rice University of the East or something like that. Is what they're called. But by aggregating that debris and bringing it together in a central location, right? Rather than the traditional concepts for debris removal, which is satellite goes, grabs one piece of debris at a higher orbital altitude, brings it down to a lower orbital altitude, releases it in the orbit in less than 25 years, goes up and grabs another one. Very energy inefficient, right? But if you can bring all of that together in a bunch of different orbits that maybe you have a centralized location to store that stuff. And even if you had to deorbit the whole infrastructure, you can save 60% of your energy cost, which is the main cost of doing business in orbit, is really relies on how much energy do I have to get from one place to another. That to me would be an efficient way to do orbital debris removal, right? Kind of a hub and spoke type of technology. Yes, sir.
This is the reason why right now you're focusing on in space, toolkit for in space.
Correct.
So right now, if I understand correctly, you're not focusing on having this toolkit on Mars or on the moon because of these deorbiting costs and all that.
We're going to talk more about that.
Okay.
and where this is applicable based on the type of technology that we're doing. Other folks are doing other technologies that are available to be used on the moon. Or we can use ours on the moon too, but more focused on the moon, more focused on Mars and things like that. But again, those basic tools just don't exist today. And that, I think, is the underpinning for helping us move to that new space economy.
Lee, can I ask one more?
No,
You know, please. You asked, on the, additive manufacturing, you still gotta get the mass. If you're bringing from Earth, it doesn't really help the problem. You still gotta get the mass up there. I mean, a big part of the problem, launch cost. And I'm thinking,
is launch cost a big part of the problem?
man, it's
I just
dropping
watched
very
two
rapidly
launches.
thanks to you guys at SpaceX,
Right.
especially thanks to Starship.
Problem.
But let me ask you something, debris you still gotta gather. You've got a gigantic mass that's getting ready to, as NASA say they're budgeting an extra $1 billion to deorbit it. Can you just maybe grab some of that down the road?
That's exactly what we want to do. Grab it, aggregate it. Some of it is garbage, just like, at home, right? Some of the stuff that you collect is garbage,
Yeah.
but a lot of it can be recycled, right? Or reused or repurposed and those kind of things. And I think that, but there's not even a place to do that, right? Do I do it at the International Space Station? Do I do it on a satellite? No, there's no scale involved. And I think that's one of the essential pieces that's missing for the new space economy is a place. Just the basic infrastructure to do those kind of things. And that's what we're building.
No, I understand. I
I know,
was
I
just
get you.
talking about the ISS as a source of mass. To be
Sure.
repurposed.
Why would we deorbit the International Space Station? It makes
It makes
very
no
little
sense to
sense to
me.
me. Let's use that great natural resource that's in orbit already, a lot of mass that's already on orbit. Why can't we repurpose all of that aluminum, use some of those scientific experiments, use some of the antennas and things like that, right? I mean, antennas were a basic design, all I got is a big parabolic dish. Let's reuse it, let's not throw it away, right? So I think that's a big piece of having that infrastructure in a place to make all of this stuff happen. Yes, sir.
It's kind of counterintuitive, but as like launch costs decrease and as fairing size increase with like stars and whatnot, you actually see the need for in-space manufacturing kind of decreasing a little bit as you can launch bigger and bigger things.
All right, so we got an 8-meter size factory. Right,
Yeah.
8 by 20 meters, right? A big, way bigger than we have today, but you can't build the Death Star with that size of type of.
So Leah, so I just realized that I don't think people online can give the questions, so maybe if we ask questions, but if you would mind repeating them or that. I think you've got at least one more slide, so maybe.
Absolutely. No, it's way more fun to interact than to speak actually, so I appreciate those questions. Yeah, yes, sir.
So we're talking about doing two pieces of that together. Right now, we can really put up so much mass because we don't believe in functioning. How are you keeping that in like one spot before bringing up another launch?
Did you pay this young man to ask me?
He needs to pay me.
Give him a name. We're gonna talk about the how behind all of this, but I kind of wanted to set up. Oh, for those online, the question was, basically, how do I basically put this whole thing together if I want to build launch infrastructure? So great lead-in question. We'll get there. It's only a 4-hour lecture, so give me a break. We're only in the first 20 minutes. So. Cool. So what are we? Again, shameless company advertising. We're building a toolkit. This is our cool video. Thank you.
Do you think there's some World Cup sponsorship?
You like that, yeah. It's- And the reason David says that is because our infrastructure looks a lot like a soccer ball or a football.
Thank you very much.
Yeah. Real Celtic. Oh, geez, we just started something, there's gonna be a war. Little Glasgow war here. But in any case, we'll talk more, a little bit about how you assemble this large infrastructure, Dave, back to your question, but, so. How do you do this? And we picked a technology called electron beam welding. Sounds really fancy, but it's really been around since the 1960s. It was invented by the Ukrainians at the Patent Institute in Kyiv. And they were able to basically shoot a beam of electrons at a piece of metal to melt it, right? In traditional welding, you have kind of two pieces of parent material, you add another piece of material, your weld stick, if you will, and you have to have an inert gas to make that happen, and there's flame and fire and things like that. Well, what the Patent Institute figured out was that I could just take an anode and a cathode, put a lot of energy into the front end, get those electrons to jump over and shoot it at a piece of metal, and you can basically join two pieces of metal using this. The biggest drawback to this technology is it has to be done in a vacuum. Because anytime those electrons hit a molecule, they want to go someplace else, right? They're electrons, they don't like each other in the first place. But then when they hit a molecule, they're going to go in a different direction, right? So doing it in a vacuum is very important. Does anybody know where there's a very large vacuum I could use? Yes, it's about 100 kilometers from everywhere. Right, so we chose electron beam welding. You could have chosen laser welding, but to be able to do laser, it's still a lot of big equipment and a lot of energy that you have to pump into a laser. And it's a beam that just keeps on going, right? Electron, which is a little shaky when you're in outer space because there's nothing holding that beam back. Right, an electron beam, I have a very short focal length that I must adhere to, right? For our little gun, it's 4 centimeters. Anything outside 4 centimeters is not getting melted, right? And anytime that gun touches anything else, it shorts out, right? So it's a very, very precise form of welding. And the reason it's used on Earth in vacuum chambers is to weld things that are really important together. For the nuclear industry, when I need to weld a 12-inch piece of steel together, electron beam can do that on a single pass. It is a very effective form of welding, but again, not used super widely because of the fact that it has to be done inside a vacuum chamber. We had them at SpaceX. We use them to weld the nozzles onto the thrust chamber of the Merlin engines. Again, super precise, low heat affected zone, so things don't get mixed up in the metallurgy and things like that. But very difficult to use outside of the vacuum chamber unless you have a big vacuum, and seems like a great place to do it in outer space. So we have teamed with an institute that is aptly named in Cambridge, UK, called the Welding Institute. They were formed in the 1800s so that the UK could learn how to weld battleships together. So UK, have you ever heard of that? Yeah.
I think it's mostly of a country a little bit south of a great country.
There it is. Sorry, the Scottish Welding Institute has not stood up yet, but I'm sure it's
I'm sure it was the Scots that created.
I'm sure the Scots created it, absolutely. Everything is credited to the Scots. But in any case, the Welding Institute in Cambridge are really the world's experts on electron beam welding and welding in general. We took an electron beam gun, the ones that we had at SpaceX were about the size of this lectern, and we shrunk it down to about the size of this water bottle. Now, I don't have to penetrate 6-inch or 12-inch steel in outer space. There's not a whole lot of that stuff. But if I can get half inch to an inch thick aluminum, I'm in really good shape for applications in outer space. So working with those folks, we've been able to build this electron beam welder. You can see our engineering Ryan there fiddling with it. And it's kind of a magic technology, because not only can you join two pieces of metal together, you can also separate two pieces of metal together, which is kind of cool. And you can do it without the traditional friction cutting that we talked about, where you're flaming off debris. Basically, by electronically steering that electron beam, you can kind of sculpt that material from the center line. You can see one of the cuts that we made there in that second picture from the left of titanium. That's 0.5 or 5 millimeter titanium, where we basically just move that material aside. Does anybody know how that's going to work in a microgravity environment?
No,
You don't think it's going to work?
in microgravity.
I don't know. Nobody knows, right? So this is very exciting. I mean, we've got technology here that nobody's done before. We know it works in one sheet, because when you sculpt to the side, it kind of reforms and melts, and it makes those little hills and a little valley that makes the cut. But in a microgravity environment, we're not quite sure what's going to happen. Is the material just going to move flat over to the side? Is it going to flame off? We don't know for sure. But we're going to do this here really soon to figure it out and find out. But that's a really important technology to be able to build things in space. You have to cut pieces of metal apart without generating a bunch of debris.
You have two launches, is that one of the two launches?
Hold on, man. I know it's exciting, but we'll get to the launches for sure. But one of the launches we will demonstrate the electron beam cutting as well. And then the additive manufacturing piece is pretty cool. You can see one of the nozzles that we printed using additive electron beam, which basically you take a wire and you stick it down the center of the electron beam, and then you can 3D print it, which is kind of neat. One of the other cool things about electron beam welding is that, and this is bad for humans, is that when you hit a piece of metal with an electron beam, it generates X-rays. And every X-ray detector that you ever walk through in an airport, X-ray in your luggage or things like that, is basically a mini electron beam welding gun. It just shoots a beam of electrons at a piece of tungsten, and it generates X-rays. And those X-rays are contained and they're low power, so it doesn't kill you probably. Right? So we're doing it a little bit higher power, no humans involved, but we'll be able to actually inspect the welds that we just made, which is kind of cool. And then if you think about it, in the military, I read what was called the counter space program. And what my mom thought that was like granite and formica and things like that. But what it really is counter space means protecting your assets in outer space and denying the enemy the ability to use their assets. And a big piece of this is understanding the intent of another satellite, right? And that's really hard to do when you just take a picture of it, right? But if I could actually spiral on up to that thing, hit it with a few X-rays, and see what's inside its stress cavity, that might give me a little bit better clue for what's actually going on inside of that satellite. So we actually won a contract today, woo-hoo, from the US Space Force to figure out how to go up and X-ray satellites and figure out why and what and how and what they're made up of and the materials that they have and kind of what the circuit boards inside might look like. So that's a very, very exciting technology that as an American company and as a former military guy, I gotta tell you, is really important for our country as well. Yes, sir.
So you mentioned the welding, cutting, and the X-ray. Is that meant to all be with the same tool, or you have
Same tool. It's like magic. So cool. So the first product we want to build is actually an end effector for a robotic arm, right? And I don't care whose satellite it is. I don't care if it's on a satellite itself, but if I can integrate easily with the variety of different servicing missions that are out there, and there are a bunch of them, right? Whether it's Northrop Grumman, who's getting ready to launch a servicing vehicle, called OSAM-1, you may have heard of it, or RSGS. I don't know, again, another acronym, I don't know what the hell it means. But there's a bunch of different servicing missions that are getting ready to launch here. If I could put one of these things on it cheaply, a robotic arm that has the toolkit on it, I can turn that, satellite that just does refueling of satellites into a full up satellite service station, right? Where I can change give you gas, but I can also change your oil, wash your windshield, and change your spark plug, right? The whole 9 yards. So that's kind of the first product that we want to go do. And, all of these companies, and many of these space companies in the new space economy have really great PowerPoints, right? And we don't do PowerPoint engineering, we do real engineering, we build real stuff. And I think that's super important. And part of building real stuff is you can't say you're a space company until you bend to outer space, right? And we'll talk a little bit more about that. Everybody hanging in? We doing all right? I don't have 3 more hours left, right, David? Okay, I want to eat. I do want to eat. Right. So as I said, we've developed the electron beam. We've done cutting in vacuum. We've done additive in vacuum. We know we can generate X-rays and all of those kind of things. The next thing that we really need to do is go figure out how does this work in the vacuum and microgravity environment. So I'm not saying what rocket that is, but we have 2 flights coming up. And those flights are first the suborbital flight, and second an orbital flight. So remember, I just need vacuum and I need microgravity to test this technology out. And I hear that there's this little rocket that knows how to land, right? So getting my stuff back and being able to examine those samples that I get back, as well as getting my welding back, is a really important thing. So we're very excited about these flight opportunities. I'll go back to the flight opportunities. I don't say much about them because, is there any members of the press here? Does everybody promise to be quiet? So we're going to launch this thing on the stage 1 of a particular launch vehicle that lands. I won't say which launch vehicle that is. But back in the day, we took, anybody ever been camping? Yeah, of course, right? Anybody ever been camping where they have bears? Yes. So there's these things called bear vaults. So back in the day, we wanted to fly some patches and some American flags on a rocket so that you can give folks stuff that's been flown in space, right? So we basically took 2 bear vaults and muffler clamped it to the top of the first stage because we knew it was going to land. And that company still does that today. So I'm like, maybe if we design our experiment to look like 2 bear vaults, they won't notice. And somehow I was able to convince them to do this. So in late January, early February, we'll find our welder with 6 welding coupons on it. And how do I go back? Can I go back? Am I allowed to go back ever? Yes. Yep. So 2 bear vaults attached to one another by a little umbilical, doesn't even talk to the rocket. And in this bear vault is the welder with 6 welding coupons on a little turntable. And after stage separation, the rocket basically flips over and is falling for about 2 minutes. So you got vacuum and you got microgravity for about 2 minutes. I need 42 seconds to weld 6 coupons that NASA and the European Space Agency said these type of aluminum are really important, really prevalent in outer space. So if you could do that, we would be happy. We'll do all of the inspection for you. We'll do all the metallurgy. We'll write papers. We'll sing your praises from the high mountains. Great. We got to make it work too, which is pretty important. But that's the first one. We'll get those samples back. And the second one is going to be on Transporter 11 on the 1st of June. So you're all invited to the launch. Come on up to Vandenberg for that. And we'll deploy off, and basically we're welding a beer keg in outer space. That's here. So imagine a beer keg, and you can kind of see it, there by that gentleman there, but we cut the top off of the beer keg. We kind of tack weld it together on the ground, so it's kind of open, to the vacuum of outer space. And then once we deploy off of the stack of satellites that SpaceX is, oh shit, that company perhaps is launching into outer space, then we will actually weld the beer keg back together. We will pressurize the whole thing. So we just created the first pressure vessel ever made in outer space, which will be kind of cool. Then we'll take an X-ray of it and make sure that that weld is good. And then we'll cut it open and celebrate the party. We won't get it back, but that's kind of the second of the demonstration missions that we're going to be doing in June. So 2 launches in the next 8 months. Yeah, that's it. Yes, sir.
This isn't fully related to, I guess, answer that question, but why doesn't, I guess, the particular company make this like a product? Because this seems like a phenomenal sample return kind of system.
You'll have to talk to those other guys.
Okay.
Yeah, I don't think they want to advertise because they're not making a hell of a lot of money on it,
Okay.
frankly. But I think it would be great, and we're trying to get other. I'm happy to sell kind of like or give away to universities. This is a great way to do a suborbital launch. Get about 2 minutes of weightlessness and vacuum for anybody's experiment. So I'm working with my friends at said company to make this a reality for many more people. So I think it's a great capability, right? Okay. All right, ready to shift gears a little bit? Okay. Would you build the Empire State Building in New Jersey, put it on a truck, and take it to New York City? No, probably not. Sounds stupid. Yeah, that's how we've been doing it in outer space for 60 years, right? We basically build infrastructure on the ground, and inside the payload accommodation of a rocket, and launch it into outer space. It makes absolutely no sense. Yes, the space station has served us very well, but we need to move beyond that. And if you look at all of the commercial LEO destinations that NASA has picked so far, God bless them all. I see friends with Axiom shirts on here, great capabilities and things like that. But it's basically the same way we've always done it. So it seems like an industry that's pretty ripe for being disrupted, right? And I think if we can build it where you need it, that could change the way we do things in our space, the number of people. So our idea is the football, soccer ball. You can build any shape you really want to build, that's fine. But a sphere has a lot of great characteristics, the best area per unit mass, all of the forces are equally distributed in a sphere. You have a low cross section for micrometeorites. A lot of things are really good about building a sphere. So we chose a soccer ball, pentagons and hexagons. If I stack them flat, IKEA style, everybody likes to reassemble IKEA furniture inside a payload fairing. Someday I'll melt metal down and make my own pentagons and hexagons, but for now, launching that flat pack inside and then rebuilding that soccer ball in outer space is the concept. And you can build really big infrastructure by doing it that way. Maybe. You'll see how. So, second stage of generic rocket. Little payload there. Pentagons and hexagons. Cylindrical part is a traditional satellite piece. Then I've got everything stacked up nice and neatly. A little satellite and robotic arms unfold. They're studying what the Space Force will be something like this in outer space. They say one robotic arm is dumb. It's not redundant, it's too complex, it's too expensive, do 2 smaller walking robotic arms, you gotta chase video at some point. Basically taking those pentagons and hexagons and latching them together doesn't give you airtightness, it doesn't give you necessarily the rigidity that you want in a permanent structure in outer space, but it gets you more rocket, right? It's everything in the right spot. And everyone's like, oh my goodness, it's such a hard robotics problem. Well, the doc's doing, eye surgery during robotics. This is way less complex. This is a very deterministic dual path. I know exactly that part A needs to go next to part B, which needs to go next to part C, and I know exactly where those things line up. I put all those pentagons and hexagons together. And then I gotta weld them together to make a rigid, airtight structure. So I basically take the robotic arm, use my electron beam welding to stitch this whole thing. Now it's an empty volume, granted. So I gotta get more stuff out there. But on a single launch, using Starship, I can go 4 times the volume of the International Space Station on one launch, and then assemble it in about 6 weeks. The International Space Station took tens of launches, it took a decade to put together, right? So this will really change the game in my estimation. Oh, you can be a part of the journey. Look at that. Again, not a shameless advertisement, but we think that building things in space is really, really important, and to get that scale and size. This is just one way you can do it. There are other ways you can do it as well.
So for like a structure that big, how do you make sure everything's aligned or from gradient? One side is facing Earth, one side is open space.
Yeah, it's a great question. I think there's gonna have to be some thermal stabilization. And you're gonna have to actually rotisserie the structure a little bit, so you're gonna have some propulsion on it, things like that. But, you know, this is another thing that we're testing with the welding, and even these first coupons, how big of a gap can I tolerate between those two pieces of metal? I can't even answer that basic question today. I told NASA and the NASA contract I won that I can build this thing in 2028, so I better get on it. So 2024, we're gonna start welding in outer space, then we're gonna build a pressure vessel in outer space. By 2028, 4 years from now, we're gonna be able to do this kind of assembly, and hopefully we'll figure those things out. But it's a great question. Something to think about. Oh,
I have a question.
yes,
Is that intended for human habitation?
it can be,
Okay,
yeah, but I don't think that's the killer app, frankly.
okay, what do you think it is?
I think in space manufacturing, where you really need the scale is the killer app. Yeah.
Because we don't build a lot of round houses.
Would you if you could?
No,
Why not?
it's weird. Have you ever been in like, yeah, have you ever been in like a house that's cylindrical?
You can't go sit in the corner? No.
Your depth perception is like, it's a very uncomfortable experience.
Yeah.
So I was just curious.
I think a roundhouse is better than a cylindrical house. I can outfit it however you want it. If you want square walls inside, sure.
Okay.
Again, but I get more area and volume per unit mass than any other shape. Doesn't have to be the shape. I just think this is the most efficient shape to be able to do at least the initial instantiations of what we want to build. Yeah.
Would this be pressurized if it's certain space manufacturing?
Huh?
Okay,
Or maybe not.
well, if it's not pressurized, what, I guess, the point of the like structure?
A place to do it. Right? We need a place to host all of this equipment for in-space manufacturing, for pharmaceuticals and things like that. Or maybe I just want you to do this, maybe not on the side of the too. Yeah, so this is one of the applications, and this is what I would call Spaceport division. It's kind of on this Pac-Man, if you will, right? That kind of opens up. I bring your satellite that has a problem, your Chinese satellite, and bring it inside, kind of figure out what's going on with it, maybe fix it, maybe change out a component. Maybe I'm a Walmart in space, right? I'm a logistics depot that I can hold a bunch of different parts, pieces, stuff I don't want you to know about, stuff I do want you to know about inside this large infrastructure in outer space, right? So this enables us to be able to do things that we can't do today, just by building scale. Yes, sir, you had a question in the back of the full house.
The residual gases, whether it's for manufacturing or human habitation, you vent those and from.
I got a big vacuum outside, yeah. Potentially. Again, I'm more focused on building the infrastructure than I am the applications that are gonna go on inside. Now, my investors, they all wanna know, how am I gonna make money on this? And that's where the in-space manufacturing, military applications, and those kind of things kind of come into play, and that's why I talk about them because I think that's the important piece. You don't build, buildings just to build buildings. You build buildings because we want to put stuff inside of it. Yes, sir.
Did you mention the volume or something like that?
Yeah, I think I did.
I didn't.
I think I did. It's 4 times the volume of the International Space Station. International Space Station on the order of 1,000 cubic meters. So 4,000 cubic meters on a single Starship. On a single Falcon 9, you basically launch the same size as the International Space Station. Around 1,000 cubic meters. So that's 20 meters in diameter sphere. Just to give you 67 feet for those who are not metric.
Yeah, you mentioned the robotic arm. Are you traditionally, the robotic arm has been provided by the Canadian Space Agency? And are you working, is the Spaceport working with any counterpart, or are you, is that separate?
We have talked to a lot, there are a lot of cool robotic arms, including some in Scotland, by the way, that want to use space robotics, which is very, very cool. And, that Canadian arm, again, an amazing piece of technology, but I hate to even hazard the price tag on it. Right, so I need an arm that's costing, hundreds of thousands of dollars, not hundreds of millions of dollars. Right, so we're working with companies like Redwire, so we mentioned Redwire, great robotics company, Motive, I'm gonna miss some of these, but I don't intend to, Maxar, and several others, which we're the Canadians, by the way, not which.
MDA did that also.
MBA.
Yeah.
That is now Maxar, and
Oh.
now it's back to MBA, so that,
Yeah.
I'm having trouble keeping track of all the dates, but in any case, there's a bunch of different companies that are doing robotics that we're working with. Yes, sir.
Yeah, it's interesting. My question kind of follows up on this one. Related to the robotic arm. When I see that, it reminds me of like single task robotic arms on an automotive assembly line. And I know it's more advanced than that. But I'm just wondering, like, what do you envision as a potential for having humanoid robots like Tesla's Optimus? Because something like that has mobility, it can do a much wider range of tasks, and it's adaptable to whatever happens.
Yeah, it's a great time to be alive, isn't it?
Yeah.
Because, I don't have to bend physics to do anything that I'm talking about tonight. I don't have to go really to invention. We're at the confluence of technology, right? Where I've got this great precision robotics. I know how to do welding in outer space. I've got additive manufacturing that's booming, right? I've got all of this computational power in a very small amount of space. There's this thing called AI, I don't know what it's called, but all of these things are coming together at this very precise moment that makes all of this stuff possible. And it's a super exciting time that we hope to be able to take advantage of and incorporate into being able to help build this infrastructure that is necessary for the new space economy. Yeah, yes, sir.
For active debris removal, is the idea to become an island of things that need to be deorbited?
I'm gonna be a junkyard.
You want to be a junkyard?
Yeah, so maybe you come to my junkyard and buy something and take it and put it on your old car. Or maybe I melt it down and turn it into something else, or maybe I throw it away.
Propulsion applications, too.
Sure, absolutely.
Yeah. With a electron beam like that and a lot of mass.
Yeah, for sure. Cool, yeah.
I was wondering, is there a way like ISS to put more than one of these together, like to make the structure bigger?
Oh, yeah. Yeah, for sure. And I'll show you some pictures of like future concepts, but you can gang several of these things together. Again, if I just launch more pentagons and hexagons, I can theoretically, or squares or whatever shape you want. Now, I can build anything of any size in space as long as I have the raw material. And it just blows my mind that we don't have the capability as a nation or as a species to be able to do this. Right? And that's what we're doing. Yeah.
That shape is, so those are curved, right? Okay. Have you thought about doing flat panels that are perfectly, what's the word, hackable in 3D space?
Yeah, we thought about flat panels as well. it's harder to build a circle with flat panels.
Or no, sorry, I mean, with the hexagons and the pentagons together, but not curved. So if you
Yeah.
put that shape together, you don't have any gaps and you can theoretically build a structure that's wider by removing the inside after you get them all together.
Moving inside.
Sorry, I'm not doing a good job of explaining. So if you build a structure like that
Yeah.
with flat sides,
Uh-huh.
well, not, it's spherical, but no curve to the panels. There are some shapes that pack perfectly together like cubes, but are closer to approximating spheres. And I think pentagons and hexagons together are one of those. So if you could build multiple of those together, you could get a huge internal volume by removing the inside of the other panels once they're joined together. Have y'all thought?
Let's have a technical interchange meeting after this and discuss that. That's an interesting concept. I don't think we've thought about that.
Do y'all work with Aurelia?
Yeah, yeah, we're gonna do a bond comment with them here pretty soon. Yeah, anybody knows what a bond comment is?
Yeah.
Okay.
No.
You want to know? Oh, so it's an airplane that flies kind of parabolic arcs, so you get about 30-ish seconds of weightlessness by doing this. So we're gonna take a vacuum chamber with the welder inside the vomit comet. If you've ever been on an airplane that holds negative G's, you'll know why they call it the vomit comet. Using the experiment, yeah. NASA doesn't fly them, it's all commercial flying. So I mentioned, a Starship, if you build something really huge, we are really launch agnostic, which our friends at other companies that are building these things are very much tied to a specific launcher that they have to be to fit in that right diameter. So I can just adjust the size of those panels in order to do this, and I don't really care whatever the customer wants me size wise, I can fit or do. We were fortunate enough to be selected by NASA for the Collaborations for Commercial Space Capabilities 2 contract. Everybody knows CCS and 2, but to stand alongside of SpaceX and Blue Origin and Northrop Grumman, and all of these other amazing companies as a new startup. I applaud NASA for really sticking their neck out there for us. They don't do that as often as I think they want to do that, and really stoked about it. And old friend Phil McAllister, who runs the commercial space division, basically said, if these guys pull this stuff off, it's really going to change the way we do this. So we're super excited and grateful to NASA. Somebody asked about getting these things together. There's kind of a concept for tying 4 of these soccer balls together. So with that, we're at almost an hour. I appreciate your indulgence and my goofiness, and this has been really fun, and I'm happy to answer any questions in the time we have remaining. Stick around after, David's getting hungry, but we're happy, and I thank you so much for your time.
Yes, yeah, I wanted to wait till the end. I wanted to see the punchline. I mean, I'm completely with you on building the infrastructure,
Yeah.
And you talked about building the railroad, right, out the west to see gold and everything, and when Columbus left Europe, he said, I'm going to get the spices.
Right.
So both cases, they knew what they were going for, right?
Yeah.
So what, in your view, is the spice in outer space? Like, what is the thing that everybody's gonna pay money and take their family to space for?
So I can speculate on what the spice is. And my investors ask me the exact same, like, how do you monetize it?
Yeah.
And, I got the same exact question with SpaceX back in 2010. There's no market for a commercial launch. The government will never touch you because you're not blowing on Lockheed Martin. All of this stuff is being done offshore overseas, and they're losing money on it. So why should the government support you, right? So there's a certain enabling function. The fact that I can buy 2 launches for less than a certain amount of money that one might pay for a house is pretty awesome, right? And it enabled a whole new industry to come on board. And I think that scale in space enables this whole new industry. And I think the first slice is gonna be stuff that we can't do on Earth. And I believe the pharmaceutical industry, who made a substantive investment in where my axiom then go.
Well,
Great. Right, they made a substantive investment in axiom. It's starting to see that future where things that you can't make on Earth are being made in the space.
yeah, I'll offer my own thoughts, but I mean, I feel like, you know, the whole reason when Columbus left Europe, he went for a certain thing, but the best thing came out of what he went for, nobody had any idea about.
Exactly.
So I think that's why we're going.
It's hard to solve.
Yeah.
Build it and they will come.
Yeah,
Right?
right. It always takes somebody with a vision to say, I'm gonna go do this, right? And I think both you and I are in the business of trying to provide. Look, let's just go and we're gonna make all these things available. We're gonna give all these tools.
Right.
And let's see what we can find. So,
I hope you're right.
yeah, I'm sure. So.
Right.
A number of years ago, there was a lot of talk about the inflatables. What, in your opinion, is the major benefit of the buckyballs as opposed to the inflatables?
I will not take any of that.
It's rice. You can say.
Buckyballs
Yeah. Sorry, conversation.
So the inflatables, where we are with materials technology, they're kind of limited in the size of the fibers that you can build for the inflatables today. They're not a rigid structure, so they move when you move, and we're backing a lot of debris and things like that. Plus, they have a center structure. You can't really put anything on the sides of that inflatable, right? If I weld to that inflatable, you're in deep trouble with it.
No lacking, no storing, no.
Yeah.
Okay.
And again, a limited amount of size. Great next step, but ultimately, I don't think there's one. I mean, go ask, Mr. Biggerman. Yeah.
Yeah, so, I have a question about radiation when it comes to like electronic lasers. Is that in the consideration when putting other particles inside the panel and causing different types of like cations and, different electrons?
So,
Can you repeat the question?
oh, sure. So the question was about, the different type of radiation that you might generate when you, hit a piece of metal with electrons. The research that we've done and the experimentation that we've done shows that X-rays are the most harmful type of radiation that we do. And we're at so low power, it's even contained by our vacuum chamber and our little tiny 2-foot by 2-foot vacuum chamber. So I don't think it's gonna be an issue, but again, we don't know. So we'll have to go figure that piece out too. We're doing a bunch of testing, with a well-instrumented, chamber to be able to figure out what other forms of radiation that we. Yeah.
Okay, yeah, I like the way you started things out with like the, with talking about like how important it is for companies to start with thinking about having a purpose and a goal of like, what's the ultimate goal? I mean, it's gotta be something that would benefit humanity, I would think. And it's gotta be profitable or else it can't happen. So that was really good. But that's what I'm wondering.
That's the government.
Yeah.
You know, all of those ventures you mentioned, who were they backed by at first?
The government, right?
Exactly. So the government is starting to step up.
But it gets good when the government gets out of the game, right?
100%.
So that's where we're all hit, right?
Right. Yeah. Sorry.
But like, I mean, if I hypothetically was a potential investor, I mean, my biggest question is how can you scale this up such that it's profitable? Because I mean, it almost looks like we're looking at prototype stuff and I've heard, the prototype's very easy, but manufacturing at scale is extremely difficult.
Yeah, no, so we are commoditizing and commercializing from a very early stage, right? So next year, we will have a product to sell, which is that end effector or a robotic arm that can do the welding, that can do the inspection piece, that can do the additive manufacturing, and that can do the cutting. That I want to attach to anyone who does a servicing mission, anybody who has a satellite, they want to make it cheap enough for them to be able to do that, so they can inspect their own satellite, fix their own satellite, and things like that. I tried to sell it to Axiom and was lucky. Stuff that, so until you can prove it in outer space, I don't want to talk. So I'm gonna talk to somebody in space. But in any case,
July, right?
hopefully in January.
Yeah.
But, yeah, so I think you have to have a product, you have to sell that product, you have to make money on that product, which I honestly believe we can do with the number of service missions and the number of stations that are out there and the number of folks that are building relatively large satellites, in the KT space, who are building satellites to take advantage of the scale of Starship. I think there's a market for this.
I think a comment on the investment side you have to think about is there's still a transition from where we were to where we're going. And the rise in all sorts of commercial space applications, Axiom, Intuitive, ThinkOrbital, lots of other companies. The market, the venture capitalists, they're used to like, I get my money back in 18 months. That's not a space market. So they're having to change their calculus. And that's that's happening because of all the successes of all these other companies doing stuff that we didn't think we could do. And so that becomes the picture. They start to, if they're doing a proper assessment, and I'm not selling for ThinkOrbital either, I don't have any shares in them, but the things that Axiom are doing and all these other companies are doing is a whole new world, and they all want to make money. This is the whole, NASA no longer gives you money to build one thing and then they take it from you. They give you money to develop something that you can then sell. You rise or fall by your own ability to do that. The government still needs to be there as that entertainment. But the investment arm is changing. And it's changing because of these other successes, and they start to see space as a place to look for those trends. And they're going to have to adjust their thinking from 18 months to 5 years and potentially even longer. Some of the bigger pictures like asteroid mining, they're a 30-year horizon. It's a great idea actually, but it's a 30-year horizon, and that's too much for current investors. The 10 years from now, it might not be too much. It might be something we start to get better. So there's a kind of chicken and egg in terms of the investment side, but the success of a lot of these companies who've gone out on their own, and it's happening internationally, is really changing the dynamic. And I mean, I'm optimistic for how we're going to explore space without, even though NASA is such a great thing for us here. You know, at some point we're not going to need them until they get us to Mars, and then they'll be like, "What do you build on Mars?" Is all this question. So there's a lot of changes happening, and I think this is the kind of thing. This is why I was keen to have Lee come and talk to us, because this is just one example of the kind of things that we need to see happening. It may not work, you know, you can't guarantee it, but I think this is where we need to. What was science fiction in the 70s is actually real conversations with money at the end of it today. And this is the kind of thing. I mean, O'Neill envisaged all this stuff anyway, but it was cartoons. Now there's real technology behind it, and I think you have to think 100 years from now, we won't be alive to see it, but this is where they start on that road. So I'm sorry, that's my little pitch for the exploring space. But.
Well, I wanted to comment a little bit. You mentioned that, you know, we're going there to make money. And I think that's just what we have to do. We go there. So I think the best thing about going is all of the things that we can't do anywhere else. The printing of 3D organs and microgravity. There's no bigger fan than myself anyway for that kind of activity. Imagine being able to print an organ on orbit and put it in a small vehicle and fly it right back to your hospital, right? That's the kind of stuff that we need to do, but we can't do it continually if we can't make money. You gotta pay the paychecks of the people that put all that equipment there. So making money, you have to make money. Otherwise you can't stay in business and you can't do any good, right? But the real reason for going is to do good or to be, you know, inspirational for it.
And the obstacle, and I think we touched on this, the obstacle has always been, it costs $100 million just to get there. Not anymore.
Yeah, thanks to SpaceX. Yeah.
And that's a big change as well.
Yeah.
You know, we're in the nerd world here. I keep going on forever. But are there any questions before we call a halt this evening?
There was some online.
Oh, it was a question online. I need to.
Yep, I got. Steve asked, will you talk in a little more detail about methods for ABR?
ADR, active debris remediation. Or removal, depending on who you talk to. And you know, this traditional concept and concept of operations really is, again, one satellite goes and grabs a piece of junk, takes it down to a lower orbit, releases it, goes and grabs another piece of junk, and you know, again, very inefficient way to do recycling. Our concept is aggregation for debris removal. We actually submitted it's called a NASA NIAC. I don't even know what a NIAC stands for, but it's like a future far out kind of crazy idea stage stuff. And you know, an electron beam is a beam of negatively charged ions, and what attracts negative and positive. Right? If I can put a positive charge on a piece of junk and I have a negative thing, I can go attract your beam. I mean, that would be cool, right? So I think, you know, the debris remediation piece, I look at debris remediation like global warming. Everybody knows debris is a problem. Nobody wants to pay for it. Right? So we as a society, as a civilization, have to figure out who's going to make debris remediation happen. I think the Space Force is starting to see where it's having operational impacts. And the Space Force is all about what they call dynamic space operations. Traditionally, space operations have been static, you know, governed by Newton and Kepler, you're going around and around. You don't fly an airplane like that. You move, you shuck, you dive, you go to this orbit, you go to that orbit, you go over here, you go over there. Dynamic space operations. In order to do that, you've got to know where the debris is, and you've got to be able to avoid it or get rid of it. Right. So I think that will eventually really start to get. How many times do they maneuver the space station a day for debris today? But it's like 10 to 15 times a day where they have to do some type of maneuver to get out of the way of the space junk. So it's becoming a little problem. And everyone's like, oh, if you aggregated with all of the space junk, it would fit in the Walmart parking lot. I'm like, yeah, but if I get hit by a peak like going 17 miles to 500 miles an hour, I'm toast.
NASA just dropped a toolbox.
Yeah. So we got to figure that piece out. And I think
and there will be a talk in February specifically on space debris and remediation and so on. So it is a real. I mean, it's an important topic.
Yeah,
is there any other? Thanks for bringing that up, Liza. I forgot that.
Yeah, we got a couple. So Sarah asked, I'm seeing a lot of Air Force, NASA getting jobs at rocket companies and primes, etc. Can they adapt to the private sector without slowing them down? How did you adapt to work at SpaceX?
You know, when I walked in the room for my first meeting with SpaceX, nobody stood up and called me sir. I didn't have staff of 30 people following me around. It was a huge adjustment. I got to tell you. And you know, government service is great. It's important, but it's very different when you have a profit motive that you've got to go take care of. And it was a big, you know, change in the way that I had done business in the government. And in the government, most people in the government are technical. Even if you're an engineer, you're still a technical program manager. Very few government employees, even at venerable NASA, actually touch flight hardware. Elon's expectation was, you're an engineer, you do engineering. I don't care if you're a vice president or if you're the janitor. You know, you are a part of a technical company. You have to have that technical prowess. And relearning that stuff that I learned 35 years ago at the Air Force Academy was not easy. But I had to do it and we did it. By the time I left my first assignment at SpaceX, I was being able to do, you know, flow calcs for, you know, pumping liquid oxygen into rockets, right? And you have the skill, and it's like a foreign language for those students. I think it's a really important lesson, actually. You know, engineering is like a foreign language. If you don't use it, you lose. Or muscles or anything like that, right? This is a skill that atrophies. So be hands-on, use that skill. Even if you're in a job that you don't necessarily need that skill, find ways to use that skill, whether it's working on your car or building a space station. It's really important.
Maybe last question.
Yeah, I'll do the last one. So Sarah also asked, has NASA fundamentally changed their mindset about the private sector because of SpaceX?
I dare not speak for
I
NASA.
can answer that, because he's beholden to SpaceX and everybody else. Actually, for the first time, in my 20 years in Houston, there was a strategic planning exercise, with only about 20 of us there, hosted and driven by NASA. So Vanessa Weish, who's the director of the Johnson Space Center, has a vision because of how NASA overall has changed in their interaction with commercial companies. They're having to adapt. They don't just do what they do, give money, take the thing, what we talked about earlier. So they really want to support that. And of course, Johnson's interested in the region, Houston and Texas overall. But that's a different dynamic. Those conversations hadn't happened in the past because NASA had their own mission that was very focused on, and they're still focused on the mission, but the approach is very different now. And so they want to be able to take advantage of all that innovation in a better way that they have been. There's still a big bureaucracy, it's still not easy, but that's what's happening. And I think that's another change that's happening on the government side of space, is that they're trying to take advantage of all of these great ideas that are coming out. People, many of whom came from NASA or Air Force and went into these commercial entities, because you can't buy that kind of experience and knowledge. But it is a really exciting time to see that change. And NASA is maybe one of the slower adopters, but they are working, and you've got to give Vanessa a lot of credit for what she's trying to do. And I can say that because I don't have any money from NASA.
So I'll give you my thought on that. I worked at JSC for about 35 years before I moved to Axiom, beginning of this year. And I think it has fundamentally shifted. And they know, after we let those commercial contracts, I was working at Ryan at the time, we let those commercial contracts go for, the commercial crew, commercial cargo. There were a lot of doubts, but there's no doubt anymore. Commercial cargo, commercial crew, best thing we ever did, right? In terms of money, best thing we ever did. And you can't deny that, and NASA oversaw all of that, and it's been as safe as anything else we've done. It's not always going to be safe. We worry about that, but they did a great job, and I think they're leaning into industry on all this other stuff. The biggest evidence that I've seen is that recently JSC and state of Texas announced a $200 million educational facility, and their NASA JSC is planning to have space there for companies to come, and they can rent a small space, but they'll be right there amongst all of NASA, so they can lean in on the technical expertise that's there.
It's called Exploration Park, and
Yeah.
speaker in March might probably talk about that.
That's
another
much
change.
All right.
Unfortunately, yeah, I mean, when Boeing got fly, Boeing got twice, God bless them, they're great Americans, but they got twice as much money as SpaceX.
I know.
And SpaceX flew, 3.5 years ago now?
Yeah. Well, there's a way to do commercial space, and there's the old way of doing commercial space, and you need to pick which one you want to do, right? The new way or the old way, and I think that writing's on the wall, right?
I think you're right, and I hope you're right, but again, you're batting 500 on one program. So this does not make a strategy for NASA, in my estimation, yet. I hope it does.
Yeah.
All right, since Alex is a student, I'll let him ask a question before we can shut down the shop.
I was gonna say, another reason I think to be incredibly bullish is that the Commercial Low Earth Orbit Development Program released their request to industry for feedback just a couple months ago. And we got over 800 comments. And this will be the first time in history that a NASA program will have baseline requirements with industry feedback. So that tells you too that we're starting to take industry feedback a lot more seriously, and they're becoming bigger and bigger partners.
Thank you.
And that's the future as well, right? These guys sit here and a couple of them out there. So Lee, again, it's been a great good presentation, but it's also been a great conversation. So I appreciate everybody here taking the time and also being participants in this. You can see why we were excited to bring you here. You can see some of the things that's happening. And I don't think he's alone. When he talks about this new space economy, there's many people, many companies that are making that happen. And we're hoping a lot will happen here in Houston, even though Colorado might have
things that people learn how, like pointy things and snow. Anyway, thanks again, and please, again, John. Do we have another toast to the?
Yeah. And we have to do the obligatory selfie, yes, I know. Thank you. All right, have a good night.
Yeah, yeah.